we look at this heat transfer subject, see, we are speaking about the two words here. First one is heat and the other one is transfer. So heat is getting transferred from one place to the other place. So we are speaking about the heat transfer. So when do we get the heat transfer? Heat transfer will happen every time when you have a high temperature and a low temperature combination. Okay, you can take any given example. Maybe you can take a cup of coffee placed on a table. So when you place a cup of coffee here and it is at a high temperature initially, so for a period of time we know that it will leave its heat to the atmosphere. So heat always flows from the high temperature to low temperature. Okay, it always flows from the high temperature to low temperature without any effort. Without any effort. So we must have learned about something called as a second law of thermodynamics. Okay, so in the second law of thermodynamics, especially the Clausius statement, you will look at this thing. Okay, if the reverse has to happen, the heat has to flow from the low temperature space to the high temperature space, you need something called as a refrigerator. Okay, so if it has to happen in this direction, that is from high temperature to low temperature, it happens naturally without any effort. Any external effort is a more appropriate word. Okay, if the reverse has to happen here, the reverse has to happen, you should have a device called refrigerator or a AC or heat pump. Something should be there if the heat has to flow from the low temperature region to the high temperature region. Okay, so and not only this example, you can also take the example of a cool drink. Okay, maybe something like Thumbs Up or Coca-Cola placed on a table with a so and so temperature. Okay, the temperature is 15 degrees, let us say. If you keep this at a temperature that is 30 degrees in the atmosphere, what happens? For a period of times, it gets heated up and it loses heat to the atmosphere. That's why it always flows in the higher temperature to the low temperature. So heat is flowing from higher temperature atmospheric air to this one. That's why it is getting heated up. So this will be the direction here. So here, if we take a cup of coffee, here what's happening? The cup of coffee is at 50 degrees centigrade initially, and the atmosphere is at 30 degrees centigrade. So what happens here? The heat will flow from the high temperature to the low temperature automatically. So this is what is happening with the cup of coffee, and this is what is happening with a cool drink or cold drink, whatever you want to call, you can put it here. So this is the basis on which the heat transfer happens. The heat transfer will happen based on the temperature. So there is no body without a temperature in this physical world. Every body should possess a temperature, and every body will have certain kind of a temperature difference every time. Okay, our human body will have a temperature difference with the atmosphere. All right, also uh, the bodies around us, whatever the food that you want to take, will have a temperature difference. Likewise, temperature difference is there everywhere, so heat transfer will also be there everywhere. So heat transfer, where it is, means it is everywhere. Okay, whether it is industrial processes or human body, or you can call air conditioning, data centers, or huge power line transmissions, or higher transmission lines, or HVAC. heating, ventilation, and air conditioning, engineering, and you name it, whatever it might be. Okay, heat transfer is there. And one important application of the heat transfer is electronics. Okay, electronics is a very good example of the heat transfer. See, you take two phones. Here, I will take the example of Apple phone, and I'll take the example of Motorola phone. I used to use this Motorola phone previously, and the Apple phone, I used to have it with my friends. I never had it. But the point here is Apple phone will have almost zero heating. Okay, the heating is very less. But when it comes to Motorola phone, very high heating, very higher levels of heating will happen. It will get heated up every time. So why is this difference is there? Because the Apple phone has very higher level of heat transfer design is present in it. Okay, and here in the Motorola phone, very poor level of heat transfer design is present. That is the reason why this is getting very less heat, and the Motorola phone is getting very higher heat. So likewise in electronics industry is booming industry as of now. Everybody knows it. Okay, you use it as a earpod, you use it as a mobile screen, or you use it as your computer, you use it as your TV, you name it. So whatever may be the case, all the electronics need appropriate cooling. Okay, so all the microprocessors will release the heat there, so every processor will release the heat. The management of the heat will require the principles of heat transfer. So if you know the principles of heat transfer appropriately, you will be able to design the electronics heating in the appropriate way, so that the better levels of cooling and better levels of heat transfer design is obtained in that one. So likewise, there are many examples which I can say where heat transfer and its principles are applicable. Okay, so let's go into the discussion today for the uh, definition of heat transfer. So when I say heat transfer, it is a form of energy that is produced due to temperature difference. So this is why, this is how we define the heat transfer subject as a whole. So it is a form of energy. Okay, heat transfer is a, I should not say heat transfer, I should say it as heat. Heat is a form of energy that is produced due to the temperature difference. Okay, it's a form of energy. This is important word, and the other important word is the temperature difference. Okay, this is one thing. And what is heat transfer? Heat transfer is science that deals with determination of rate of heat energy transfer. See, heat is different, heat transfer is different. This is the first heat, and the second one is heat transfer. How is heat different from the heat transfer? See, in heat, heat will be there every time you have a temperature difference. That is one part. And what is a heat transfer? In heat transfer, we will be interested in something called as rate. Rate is very important here. So you must have studied about the heat in your thermodynamics also, right? Did you learn about heat in thermodynamics? Somebody respond.
Yes, sir.
So what is the unit of heat that you have taken there?
Joules.
What is the unit of heat that you have taken? Joules. Good. So let us look at the basic difference between the heat, thermodynamics and heat transfer here. Okay. In thermodynamics, you deal with the amount of energy, whereas in heat transfer, you deal with the rate of heat energy transferred. So here amount is important, how much heat is there, that is joules is important here, whereas here rate is important, here joules per second is important. Here you will consider it as joules, here you are interested in joule per second, that is you are interested in watt. Joule per second is nothing but watt, right? So it doesn't mean that you should not use watt in thermodynamics. You must have used watt also in thermodynamics. But there also you are most focused in amount. Okay, the principles of thermodynamics are dependent on amount of energy. The principles of thermodynamics are less focused on the rate of heat energy transfer. Okay, so it doesn't mean that if I have written here joule means I should not use watts here. Okay, watts can also be used in the thermodynamics. Okay, it's a simple unit conversion you can do, but the principles that you form there, your first law of thermodynamics is zeroth law, your second law, your third law, your exergy analysis, your availability analysis, whatever the analysis that is done there is done based on something called as a continuum principle. Okay, continuum is a basic thing there. So the continuum, what it focuses is it focuses on the amount there. Okay, it doesn't focus on the rate of energy transfer. Okay, whereas in heat transfer we will be focusing on the rate of energy transfer. And one important difference that we must identify here is in the first part, in the thermodynamics, you will be dealing with something called as a equilibrium states. Okay, can somebody tell me what is a thermodynamic equilibrium? What is a thermodynamic equilibrium? Must have already studied this. What is a thermodynamic equilibrium?
When the bodies are in both physical and chemical equilibrium, we call them being in thermodynamical equilibrium.
Good. It's actually three things: physical equilibrium, chemical equilibrium, and thermal equilibrium. All these three equilibriums are present, then we call it as a thermodynamic equilibrium state. Okay. So thermal equilibrium means what? It is having the same temperature only, it will yield. Okay, whereas here in heat transfer you will have two different temperatures. Okay, heat transfer will happen because of the two different temperatures. So here in heat transfer we deal with the non equilibrium states. So here the temperature should be same in order to apply the principle here. Okay, whereas here in heat transfer even the temperatures are different, even if the uh, equilibrium is not there, physical equilibrium or the chemical equilibrium is not there, then also you can apply this heat transfer principles. So that's the basic difference between your thermodynamics and heat transfer. I hope that is clear, and let me move on to the next concept here, that is modes of heat transfer. So this is very basic for the heat transfer here. So if the heat transfer is happening, which mode it is happening, you should be able to identify. So what are the modes basically? So first mode is conduction. and the second mode is convection, and the third mode is radiation. Conduction, convection, and radiation. These are the three words which should be very clear to you. These three words you should by heart. These three words should be in your mind like anything. Okay, so this is the modes of heat transfer: conduction, convection, radiation. Conduction, convection, radiation. These three things should get printed in your mind. Maybe you can by heart or do it something like mantra or anything you can do. So this should get fed in your mind. You should feed these three things in mind. Okay, so for any given mode of heat transfer to happen, one thing is very much common. Okay, that is temperature difference. Okay, if you don't have temperature difference, you don't have heat transfer. So for the heat transfer to happen, the basic requirement is the temperature difference. Okay, so higher the temperature difference, higher the heat transfer. Lower the temperature difference, lower the heat transfer. Let me explain this with an example here. Okay, so let us say you are bathing, and you are bathing with the hot water here. Okay, so the person is there here and he is bathing, and one side we'll take cold water, and on the other side we'll take, and the cold water is at 10 degrees centigrade, and the hot water is at 90 degrees centigrade. So what is the general human body temperature? Any guesses? Anybody? What
37,
should be
sir.
the, yeah, it's around 36 or 37 degrees centigrade. 36.5 is exact. Anything. Okay, 36 let us take. So this is the normal human body temperature. So now I have taken this cold water at 10 degrees centigrade and poured on my body. Okay. When you pour it on your body, will you feel comfortable directly? Okay. Please respond, anyone.
No.
It is uncomfortable. Okay. And at the same time, you have another water here, that is a hot water. In that case also, if you pour this on your body will feel uncomfortable. Okay, it will cause damage also. So in both the cases, which one will cause the more damage? The cold water will cause, or hot water will cause more damage?
Hot water.
Hot water is having the more damage. Why? Hmm?
Temperature
Low
difference.
temperature difference.
Very good. Less delta T here, you have high delta T here. So this is also uncomfortable, this is also uncomfortable, but this is having higher delta T. That's why higher heat transfer will happen. Because of higher heat at higher levels, your body will get damaged, your skin will get damaged. So higher the delta T, higher the heat transfer. This is the point that we should understand. Okay, so like temperature difference is a base for your heat transfer to happen. I can say is a few more things here. Okay, see, do you know how the mm, electrical energy comes into the play? What is the driving force for electrical energy? If the temperature difference is the driving force for the heat energy or the heat transfer, what is the driving force for electrical energy?
Movement of
Potential.
Potential.
electrons.
Huh?
Potential difference.
Very good. It is potential difference. It is all about difference, my dear friends. So, what difference is causing it? What difference is the primary cause for it? You should understand. Okay. So for electrical energy, higher the potential difference, higher the electrical energy transfer. For the fluid to transfer or fluid flow energy, I can say. So when your fluid flow will be higher and when your fluid flow will be
Pressure,
less.
pressure difference.
Very good. So these are the primary driving force for these energies to come into the play. These energies to uh, have their own uh, play, have their own significance. What is the primary motive or the primary driving force? These are the primary driving force here: temperature difference, potential difference, and pressure difference. So here in our case, if the temperature difference is high, the heat transfer will be high. If the potential difference is high, electrical energy will be high, and the pressure difference is high, fluid flow energy will be high. So these things I would like to tell you here. And one important thing here is, when we speak about the temperature difference, we will have a temperature which is approximately ranging from maybe 15 degrees centigrade or 10 degrees, we can say, to uh, maximum 45 degrees centigrade. So the temperature that is present in India is most of the times is around 30 degrees centigrade. Whereas in cold countries, let us take cold countries, okay, the temperatures will range from minus 30 degrees centigrade to around 40 degrees centigrade. Okay, but the temperature that is present there is around 15 degrees centigrade for these cold regions. Okay, so if this is the case, what is the advantage that going to get in power plant operation? Power plant operation. So can anyone guess this? What is the advantageous thing for power plant operation? This one is advantageous or this one is advantageous?
Second one.
This cold countries 15 degrees centigrade is an advantage. Why? We should understand that power plant will operate at a maximum temperature of T max will be a constant value. Okay, it won't change from India to America. It is constant. From India to Europe, it's not going to vary, because the highest temperature that is available that any given metal can bear is constant everywhere. The metals are same everywhere. So the higher temperature, whatever may be the value, it can be 1500 degrees centigrade or it can be 150 degrees centigrade or whatever may be the value. It is constant value. You cannot vary this. Okay. So the power plant efficiency or the power plant capacity is decided by T max and T min. What is a T min? T min is nothing but the atmospheric temperature. So the atmospheric temperature in India is just 30 degrees centigrade on an average. But whereas in cold countries, the delta T is very high. It is very high. It is very low in India, high in cold countries. That's why, because of this inherent advantage the cold countries have, they could produce a lot of power. Okay, the power capacity of any given power plant that you establish in a cold country will be higher compared to the power capacity of a power plant that you establish in places like India or in places which are even hotter than India. So so I hope you got what is the importance of this heat transfer and the temperature difference there. So the temperature difference is playing a crucial role in the power production also. So this is the basic thing that I would like to tell you about the heat transfer and its importance, especially in view of temperature difference. Heat transfer is nothing but temperature difference. We know the importance of temperature difference. You know the importance of heat transfer also. So now let us move to this thing, the modes of heat transfer: conduction, convection, and radiation. So here in unit 1, we will see a basic introduction to each mode of heat transfer. What is the basic difference between these three we will see in the first unit, and in the second unit we will study the conduction in depth. Even in the first unit also we will study the conduction in depth, and in third unit you will have convection, fourth unit is also about convection, and fifth unit is about radiation. So about each mode of heat transfer you will have in-depth discussion as we move forward in our syllabus. Okay, initially we will look at the introduction to these three things in the first unit. So now let us start our discussion with conduction. So when it comes to conduction, you should understand, for any given mode of heat transfer, first thing to be understood is what is the governing law. Governing law. And let us put this as second thing. Okay, first thing we will put it as mechanism of heat transfer. Mechanism of heat transfer, governing law. And the third thing is the mathematical quantification. So these are the three basic things which you should have in mind for any given mode of heat transfer. Okay, when it comes to conduction, the mechanism of heat transfer is lattice vibration, it's not writing properly somehow, and flow of free electrons. Flow of free electrons. This is basically predominant in your solids. Okay, this is for solids. Whereas if you go for fluids, the mechanism of heat transfer is molecular diffusion and molecular collision. Molecular diffusion and molecular collision. So in solids, lattice vibration and flow of free electrons. In fluids, molecular diffusion and molecular collision. So these words you remember. Okay, and what do they mean? Okay, let us try to look at that first. Okay, see, conduction is basically a heat transfer that is present in solids. Okay, this is predominantly happens in solids. Okay, so what we can say is conduction is nothing but the solid heat transfer. Okay, it is mostly happens in the solids. Most of the times it is a solid heat transfer only. Okay, so let us take a solid here. Okay, the solid can be anything. Maybe I will take a rod here, a steel rod. This is a steel rod, and what I'm doing is I will be heating it under a flame. Okay, let me take this as my flame, and I am heating it. So when I'm heating it, what happens within the body? This body will raise its temperature, and as you leave it for so much of time, you can see it is becoming so red hot. So why is it becoming red hot? Because there is something called as a conduction that is happening in it. Okay, as the temperature increases, okay, can we touch this with hand? So this cannot, this can be touched with hand, and this cannot be touched. See, why can't you touch it at 100 degrees centigrade, and why can you touch it at 20 degrees centigrade? What is the reason for it? Can anyone tell me?
Our body temperature.
Very good. Our body temperature.
Rate of heat transfer is more at 100 degrees Celsius.
Very good. Very good. See, basically, when you are touching it, your conduction heat transfer is happening. And the conduction heat transfer, what it is doing is the lattice vibration. Your body will have certain lattice, right? And this lattice is vibrating very fastly, and the heat transfer is happening very fastly. Okay, so from a given body to the adjacent body, the heat is transferred at a faster rate. That's why your hand is not in position to withstand that particular higher energy there. Okay, the energy is so high because from one electron to the other electron, the heat transfer is happening so fast. So in the molecule, you will have lattice, right? So this lattice is transferring the energy from one particle to the next particle at a very higher rate. That's why your heat transfer is happening at a faster rate. So here the lattice is playing this role here. So in a solid, what happens is all your particles are placed side by side like this. Okay, that's why the energy transfer can happen very easily from one particle to the adjacent one very fast, one atom to the adjacent one at a very faster rate. Okay, so that is the reason why your heat transfer is happening very happening at a very higher rate, and at a slower rate. Okay, this is one thing. And when it comes to fluids, it is a molecular diffusion. In fluids, what happens is your uh, molecules are not placed very much like your solid. Okay, here the molecules are placed at distances. Even if they are very close to each other, they are not solidly packed. That's why heat energy will have to happen through the diffusion. So if let us say you take a hot water being boiled on a stove. So when it is being boiled on a stove, what happens? From the bottom, the energy will get transferred to the other molecules at the top. So then it gets diffused, then it gets collides. So all this will result in something called as a molecular diffusion and molecular collision. Okay, that's why molecular diffusion and molecular collision is a mechanism of heat transfer in fluids for conduction. So, see, remember these words clearly. Mechanism of heat transfer is very much important, and the mechanism of heat transfer in conduction for solids is lattice vibration and flow of free electrons. And if it is For fluids, it's molecular diffusion and molecular collision. Okay, so this is the first thing that you should have in mind for any given mode of heat transfer. That is a mechanism of heat transfer. And the second one is governing law. What is the law governing conduction? Any guess, anybody, if you know? See, the governing law for conduction is Fourier's law of heat conduction. This is the law governing the conduction, Fourier's law of heat conduction. So how do we write it mathematically? Okay, so how do we represent the Fourier's law mathematically? So what it says is, Fourier's law of heat conduction, it says that Q is proportional to the area. Higher the area, higher the heat transfer. That's what it says. And it also says that Q will be higher if the delta T is higher. And it also says that Q will be inversely proportional to the thickness. Okay. So let us take this rod example only. Okay, so in this case what I will do is, I will take two things here. A child's case and an adult case. These two cases I will take. If the area, if you take a child is touching a hot rod, okay, a child is touching a hot rod, the area of the child will be very less, no, and the area of the adult will be very high. So what happens? Lesser area will represent lesser heat transfer, higher area will represent higher heat transfer. Okay, this is the thing. And let us take the delta T. Okay, if we take the delta T, it is same whether it is a child or adult, it is going to be the same. And when it comes to the thickness, what happens? Who will have more thickness for the skin? Childs will have or adults will have?
Adult.
Adult will have less, sorry, adult will have more thickness and the childs will have less thickness. That's why who will get the more damage for thickness? If child is touching it, immediately the hand will get damaged. If the adult is touching it, it will take little more time because of the thickness that is present for the body. So my point here is, if the thickness is higher, the heat transfer is bit less. If the thickness is very small, the heat transfer is very high. Right? And when it comes to the delta T, okay, delta T, already I gave you an example. This is the thing. Okay, 20 degrees centigrade, it can be touched with hand, and 100 degrees centigrade, you cannot touch it with hand because the delta T is so high. And when it comes to the area, higher area will, క్లాస్లో ఉన్నప్పుడు ఎందుకు సార్ అని నన్ను అడుగుతారు. క్లాస్ చెప్తున్నా కనిపించట్లేదు. So here, higher the thickness, lesser the heat transfer. Lower the thickness, higher the heat transfer. Higher the area, higher heat transfer. Lower area, lower heat transfer. And for understanding this area, you can have two different things here. You can have a finger and hand. Finger and hand. If you put a finger, just touch it, lesser heat transfer. If you put hand, high heat transfer. Okay, this one also you can look at. Okay, whereas here, child hand, when we have child hand, it will have lesser thickness So it will result in higher heat transfer. And if you have adult hand, it will result in lesser heat transfer. Okay. So these things we can understand in any given case. Okay. So these are the things proposed by Fourier first. So whatever the heat transfer by conduction will be equal to area into delta T by thickness. And to take out the proportionality constant, he will introduce a constant here called as K. This is thermal conductivity. Anyways, we will look at all of these things in detail in the next class probably. So for understanding this, we need more time. Actually, the time available today is bit less. So we will continue this discussion in the next class.